All right, so a student solved the equation x squared is equal to 132 to find the length of a diagonal of a square in centimeters. What whole number is closest to x, the length of the diagonal of the square? Okay, the diagonal of the square is, solve the equation to find the length. So we have the diagonal of the square is going to be the square root of 132. To undo x squared, the opposite of squaring something is to take the square root. So for this problem, all I actually had to do was take the square root of 132. So on your calculator, to take the square root, you're going to do second x squared, 132. And it said whole number, so I'm rounding to the place that's in front of the decimal. Well, the behind it is a 4, so a 4 leaves 11 the same, so the closest whole number was 11. Okay, number 2, the density of oxygen is 0.001429 grams per cubic centimeter. How is this number written in scientific notation? Well, when you write something in scientific notation, this is the format we are trying to fill in. We have one number in front of the decimal, followed by our other significant digits to an exponent. So here, I want my decimal to end up between the 1 and the 4. So I'm going to move it 3 times. 1, 2, 3. So that's my exponent. We have the 3. The 1 is the number in front. And then I'm going to fill in my numbers behind. So we have 4, 2, and 9. Now the final thing I have to do is decide is my exponent positive or negative. Well, this was originally a really small number, so our exponent is going to be negative. Number 3. The table shows the diagonal lengths of TV screens at a store. Order the diagonal lengths from least to greatest. When we want to put something in least to greatest, we want to make sure that they are all decimals. So we're going to use our calculator, and I'm going to change them all to decimals. The first one I'm going to do the square root of 12.25. So to do the square root, it's second x squared, 12.25, and then we get 3.5. So I'm just going to go ahead and write out the decimals afterwards. When you change a mixed number to a decimal, the whole number is not going to change, so I'm going to keep the 2 with the decimal point. To change the fraction to a decimal, I just have to divide the numerator by the denominator, so 1 divided by 6, and I get 1.6 repeating. So we're just going to add that on to the end. Here I have 37 divided by the square root of 144, so we have 37 divided by second x squared, 144. And the calculator, go ahead and type that in. We have 3.083. And finally, we're going to just divide 8 divided by 3, which is 2.6 repeating. Okay, greatest to least. Okay, so we're going to start comparing our 3's. If I add zeros behind this, this is 3 and 500 thousandths, whereas this is 3 and 83 thousandths. So I would say W is the largest. Then after W, we have Y. Then we have Z, 2.6 repeating would be greater than 2.16, and then we would have X. Okay, number 4 is kind of a similar thing. We're going to order the following from least to greatest. Again, I want to go ahead and change these all to decimals. So we're going to start with the fraction. So we have 3 divided by 25. That gets me a decimal of 0.12. And then I have the square root of 3, so second, we have x squared, and then I can type 3, and then I'm going to make sure to arrow outside of this so that I don't put the division underneath the square root sign, so right arrow out, divided by 11, and I get 0.157. Then we have 9 divided by 100, which is 0.09. And then you have pi divided by 24. So for pi, we can use 3.14 and then divide by 24. And this becomes 0.13. Okay, so when we are putting them in order from least to greatest, the first thing we're going to look at is the tens place. This one starts with a 0, so plumber Y is the smallest. We're done with that one. Then we have ones for all the rest, so we're going to look at the hundredths place. The hundredths place for W is a 2, so that is the smallest, so we're going to have W. Then between the 5 and the 3 is the next smallest, so we have Z. And then with the 5, we would have X. So that is in order from least to greatest. All right, so number 5 It says figure 1 and figure 2 are similar quadrilaterals. What proportion must be true? So the very first thing we're going to do is we're going to make sure that our sides are lined up. So thankfully for us, this picture is facing the same direction, but if it wasn't, we'd want to make sure that they were. So this corner has 3 curves. This corner has 3 curves. This one has 1. This one has 1. So this side length 8 must match up with that side length for A. Then over here, we can see that between the 3 and the 2, that 5 would match with the 3 and the 2 over here, which would be the 8. And then I can see that from the 2 to this corner that doesn't have anything, that would match with that one. So now that they are all matched up, I'll be able to match up this proportion. So A is from the figure 2. So A matches with the 8. Yep, those match together. And then B, but that one's in figure 1. So if the first half of the proportion is figure 2, the bottom half should also be figure 2. So B doesn't make any sense, or F doesn't make any sense. So 3.2 is the side that I didn't highlight. It matches with the 2. Yep, that's correct. A is on the same quadrilateral as the 3.2, so that's good on the top. And A matched with 8. G is a perfect answer. Okay, pentagon MNPQR is shown on the coordinate grid. Pentagon MNPQR is dilated with the origin as the center of dilation using the rule XY becomes 1/4 X, 1/4 Y to create pentagon M prime, N prime, P prime, Q prime, R prime. Which statement is true? Okay, 1/4. This is going to be a reduction because the scale factor is less than 1. So the new one is larger because the scale factor is greater than 1. Well, that doesn't make sense. Our scale factor is less than 1 and it's getting smaller. The new one is smaller because the scale factor is less than 1. That looks like a pretty good option to me because that's what we said. The new one is smaller because the scale factor is greater than 1. Well, 1/4 is not greater than 1. And it's larger because it's less than 1. That makes no sense. So the correct answer is G. Number 7 says the table shows coordinates of vertices of pentagon ABCD. Pentagon ABCD is dilated with a scale factor of 7/3 to create pentagon A prime, B prime, C prime, D prime. Write a rule. Okay, well, I don't have the vertices, but I have a scale factor. And when we write the rules for dilations, we always start out the same way. XY becomes this. And dilate means to multiply. So I'm simply going to say 7/3 X. 7/3 Y. We multiply by the same scale factor. This would be an enlargement because our scale factor is greater than 1. Number 8, pentagon PQRST was graphed on the coordinate grid. Pentagon PQRST was rotated 90 degrees clockwise about the origin to form pentagon P prime, Q prime, R prime, S prime, T prime. Which statement is true? Okay, rotations. The area is not equal to the of the new one is not equal to the old one. Okay, well, rotations, we don't change the size of the shape. So the area is not going to change size. The pentagon is not congruent. Well, no, I didn't change the size. We just made that decision in the first one. The perimeter is greater than the perimeter. Well, for that to happen, I would have had to change the size. I didn't change the size. The angles are congruent. We never change the angle measurements. Angles are always congruent even after dilation. So that one would be true. Okay, number 9. A transformation is applied to a figure to create a new figure on the coordinate grid. Which transformation does not preserve congruence? Okay, we're not keeping the same size. So rotations stay the same size, reflections do, translations do, dilations change the size. So just on those words alone, we should have decided dilations. Number 10, trapezoid WKRP was translated 4 units left and 5 units up on the coordinate grid. Which rule describes the transformation? Okay, so if we have a coordinate grid, we can move left and right. So left, this happens in the X. So when we move left, that moves into the negative. So we're looking for subtracting 4, which I can see is B and C, okay? And then when we move up, we're talking about Y, and that would be positive. So I want to be adding 5, so the answer is A. Okay, number 11 says rotate the following image 180 degrees counterclockwise about the origin. So counterclockwise, we are going to turn to the right. So I'm going to turn it once, 2 times to the right. Now my point is I'm going to have to write down my ordered pairs. So we have an ordered pair here at we change it. So I go right 1, up 6. So our new ordered pair is at 1, 6. Then I go right 2 up 6, so we have an ordered pair at 2, 6. I go right 2 up 2, we have an ordered pair at 2, 2. Then we come over here, I go left 1 up 2, so that would be negative 1, 2. And then from the origin, I go left 1 up 3, so that would be negative 1, 3. Then I'm going to go back to my original spot, and I can plot the points that I wrote down. So we have 1, 6, so right 1 up 6, I put a point. Then we have 2, 6, so right 2 up 6, put a point. We have 2, 2, right 2 up 2, put a point. Then we have negative 1, 2, so left 1 up 2. And then we have negative 1, 3, so left 1 up 3. And we can now connect our points and have rotated the image 180 degrees counterclockwise. All right, please make sure you've shown all work, and I will collect them.